Hello everybody, it's time to introduce Decryptor, JavaScript codebreaker, and spell check. We've got a sample text already loaded when you visit the page, and it's all set up to walk you through your first decryption session. What this does is it figures out basic ciphers like Caesar ciphers and rotation ciphers, where anything where one letter equals another letter. These letter substitution tables over here on the right are based on letter frequency analysis, and then it takes a dictionary and picks the most likely letters and gives suggestions down here. So you just click one of these suggestions and go check spelling and keep checking the spelling and clicking on suggestions until it figures out the text. Here's where you have to use a little discernment and think, academic attacks are what? Are they outer? Are they after? Or are they often? Often, if you're not sure, you can just click one and see that made it worse. So you just click it again and choose often. And that one works. That looks better because these still make sense. And then you can just keep going. Check spelling. Pick a word. Weakened seems to fit. Weakened versions of a cryptosystem. Well, that looks like cryptosystem, and it'll tell you. You can either click here or you can go over here and change the letters around manually if you want. That's another way to do it. Basically, we want to change the U into a Y. So if you type a Y here in this box, you just highlight it, and if you change that to a U, it'll switch automatically, and it'll switch them automatically over here too. And SLCU, that doesn't make sense, but this spell checker will tell you, it'll give you some suggestions over here, and you just pick the ones that make sense and keep going. SL. See, here's a word over here that looks like function, and the L is a U, so we could probably just swap these. They're close together also. That is usually a clue. If the letters are close together, that usually means they're similar in frequency. So you can just swap them and try it out. Function. SUCL as a something function, some rounds removed, cryptosystem. Well, it's not sick. Oh yeah, it's such as, because there's as right there. That makes sense. Exponentially. So basically, we have this figured out in no time. And that's pretty much how it works. We can decrypt most types of Caesar ciphers and various rotation ciphers with this decryptor here. And we're using JWin for the development. This is JWin is a little JavaScript container that I wrote that lets you do Windows-like things to your JavaScript applications. These are like little apps that run in the browser. What we've got here is the bitrot translator, which lets you create various types of rotation ciphers, and it'll translate them back and forth. You can type your own formulas into here and even generate different types of ciphers right from the beginning. And here's the default cipher it starts with, which is ROT13. Various bit rotation ciphers, we call that the bitrot translator. See, that's the ROT13 cipher. And then we can go C plus 1. There's the +1 cipher. Each letter is one more than it should be. So you can take all these ciphers and try them out. Try decrypting them and re-encrypting them and just playing around with the decryption. You just take this, paste it over here like that. You can create your own codes and your own code breaking sessions until it starts to make sense. And as you can see, these suggestions aren't very helpful. We don't have a big enough sample size here. Usually, in order to get the proper letter frequencies, you need to have a longer message sometimes. So we could try a longer message here. Let's say you intercepted more code. And we can do an initial decryption up here. You can see it already is starting to decrypt that new cipher that we just created down there. That looks like letter, and I can just almost read that now. And I know that's the because it looks like the TNE. Just change that to an H here. And letter. Let's pick that one because we know what that one is. And frequencies. Yeah, we know what those are. Let's see if it gives us the suggestion for that one now. Yep. So we're already starting to decode this message here because we've had a big enough sample. We've gotten the letter frequencies figured out from the sample, and that's compared against the common letter frequencies in cryptography. These are that's the cryptography letter frequency. But if you're trying to decode something that's like more like Google Books type of grammar, then we could use a different letter frequency table for that, and that kind of messed it up. But yeah, you'd have to basically start over with that new table. But anyway, you can choose different dictionaries here, or these aren't dictionaries. These are different letter frequency tables based on the type of sample material. Like it just gives you something to start with. It'll automatically determine the letter frequencies though based on what the it's on the session, basically whatever's pasted in there. We can restart the whole thing and decrypt that sample message again. Basically start up the code with or do our own codes down here. So I don't know, it's something to have fun with, making codes and breaking them, and helps introduce the concept of cryptanalysis and elementary code and breaking. Have fun.